The purpose of this video is to show the monitor capabilities of the DVPII service tool. On this first page, you see a menu at the top of the page. We will only be talking about monitor in this video. The column on the left shows us the pages that are available to monitor. The device overview gives us a general overview. The next 6 pages give more detailed information. The page is divided into 2 columns of variables with values, each column showing a variable name with a corresponding Boolean indicator, value, or a numeric value and unit. By clicking on a variable name, a column on the far right gives help information. For example, if we select driver status, the help column displays the various status possibilities. Above that help column is a red circle with a question mark. This will allow you to collapse the help column. If you select another variable, the help column will appear again. At the bottom of the page is overview information. Clicking on that panel will display or collapse the panel. This gives us important status and position data of what is happening at the moment. The overview is available on all the other menu options. The first detailed information page is the position controller. The position controller, the valve state, and the build C4 state indicate we are running. The demand mode shows that can open is a means of communication with the control system. Position demand indicates the position information obtained from the control system, where actual position is the actual position where the valve is at this moment. In the next column, position error configuration will show the position error detection configuration and status information. In the last column, motor resolver diagnostics will show the resolver redundancy manager, status, and configuration. Now let's look at the position demand page. On this page, you can see the information and status of the position demand that is supplied to the DVP2. On the position demand page, you can see all the positions coming from the control system. In this case, the can open adapter state indicates that we are set up to run dual can open digital communication to the control system. The can open active demand source shows we are using port 1 information at the moment. In the next 2 columns, you can see the information that has been communicated from the control system using can open port 1 and can open port 2. The control system also sends configuration information using the communication ports. Next, we will look at the alarm and shutdown status page. The alarm and shutdown status page will show you 2 sections. The top section shows the active alarms and shutdowns. Alarms and shutdown conditions that are active at this moment. As you can see, there are no alarms or shutdowns active. The second section shows the stored alarms and shutdowns. This is a log of things that have happened before but are not currently active. On top of the 2 sections, you will see the active status, which can be system shutdown, system alarm, or system normal. This is the status your valve is in now. System shutdown means the valve typically has been closed, 0% position. Alarm indicates there is an issue detected, but the valve is still operational. This condition needs to be checked and fixed either immediately or soon. System normal means we have not detected any issues with your valve. Next, we will look at the startup checks page. On this page, you can see the information that is collected during the startup checks. Every time the valve is powered up, we will do a startup check. We can see the position of the valve during the last startup check, and it is depicted by the pink and blue line. As long as the position of the valve during the check is between the red and yellow lines, the check will pass and the valve will start up and become operational. If not between the red and yellow lines, we will set an alarm or a shutdown flag. Below the graph, you can see the values that have been reported. On this specific valve, the shaft startup check is not used. Next, we will look at the resolvers page. On this page, you can see detailed information about the resolvers. The resolvers are the specific type of position sensors used to monitor the valve position. The two raw resolver values, motor 1 and motor 2 raw position, are continuously being measured by the driver. There are two values because there are two redundant resolvers connected to the motor. After applying the offset to the raw values, the two resolver scaled positions should be close to the same value, as you can see they are here. Because we have two position sensors, on the right side of the screen, you can see the redundancy manager values, which includes the resolver difference, which is the actual difference that is measured at the moment. The other values on the screen are the gain and amplitude, used in the automatic gain controller in the resolver decoding software. An amplitude between 80 and 82% would indicate that the automatic gain controller is in control. Now we will go to the last of the pages, the application versions. On this page, you can see the version information of the program file and all the application versions. Here you can see the program name, the version of the main application, which is actually controlling the valve, the service tool version, which is the screen you see at the moment, and the data reduction version, being 0, means it is not currently implemented. The other versions are for internal use and displayed for completeness. The information on the right side are the application versions that are inside the program file. This information would typically only be used by a Woodward support person, again included for completeness. This was an overview of the monitoring capabilities of the DVPII service tool. For more information on other capabilities, see the other videos in the DVPII video collection. Thanks for watching, and I hope this has been helpful.